Let's dive right into this explainer and explore a genuinely mind-bending hypothesis. What if our universe isn't a continuous stretch of space-time, but rather a discrete, perfectly coded computational engine? Today, we're unpacking a highly technical theoretical framework from the source material known as the Poole Manifold, developed by independent researcher Rooke Alan Poole. The author proposes a radical model where physical reality actually operates as a discrete, three-dimensional cellular automaton. We're going to break down exactly how this hypothesis attempts to completely rewrite our understanding of physics, cosmology, and computation itself. Here is a quick look at our agenda for this briefing. We'll start with reality as discrete computation, then look at the B5-7/S5-9 engine, proving universal logic, the cosmological proof, how to go about running the code locally, and finally, we'll wrap up with computational theology. Let's kick things off with Section 1, Reality as Discrete Computation. To start, we really need to dismantle a fundamental assumption about our universe. The core premise of this entire framework asserts that what standard continuous models call dark energy is, according to Poole, a total illusion. Instead, the author argues it's actually just the macroscopic succession flux of a discrete geometric tensor, expanding to maintain its carrying capacity. So, in this framework, space is computationally irreducible. It's not some smooth, continuous fabric. It's a literal, discrete grid calculating its next state in real time. Now, when we map standard continuous models like lambda CDM against the Poole manifold's discrete lattice, the source points out some really stark technical differences. Continuous calculus models rely on artificial smoothing fields, which, as many of you know, can spit out mathematical ghosts and infinities, but the proposed discrete lattice simulation claims to handle extreme forces very differently. It uses physical entropy venting via non-Hermitian dissipation. Basically, this means the lattice physically vents thermal entropy whenever the local density exceeds a high threshold of 7.0. By doing this, it naturally executes Morikawa scattering mathematics, completely eliminating the need for invisible dark matter. Moving right along to Section 2, the B57/S59 computational engine. What's absolutely fascinating here is the exact engine proposed to drive this physical reality. According to the research, everything in the Poole manifold runs on a singular minimal rule set, B5/7/S5/9, specifically with prime resonance sharpening. In this totalistic cellular automaton rule, a dead cell is born if it has between 5 and 7 active neighbors, and a live cell survives if it has between 5 and 9. The author highlights this prime resonance as the atomic vocabulary for stable computation. It places sharp Gaussian peaks exclusively at prime numbers, and because primes are mathematically irreducible, the theory states this ensures interference-free frequencies, creating the perfect Goldilocks zone for sustained oscillation and self-repair. Derived entirely from that prime resonance geometry, the source material outlines a succession flux constant of exactly 0.3095. The author claims this number emerges naturally when the lattice maintains a 40% thermodynamic equilibrium density. So rather than being retroactively fitted to match telescope data, it is presented as a pure analytical derivation that fundamentally replaces the need for standard dark energy parameters. The universe expands simply because it is computing itself at the exact rate the succession flux constant requires. That brings us to Section 3, proving universal logic systems. Of course, the crucial point is proving that this geometric engine can actually compute complex logic. The researchers claim to have successfully built incredibly specific logic primitives directly within this discrete lattice. We're talking about a functionally complete set of logic gates, like a distributed half-adder with Venturi chokes, and a 2-bit ripple carry adder that uses temporal caching to verify calculations. But even more central to their thesis are the self-healing memory systems, specifically the V27 immortal latch. The research shows these cross-coupled latches can survive and actively repair themselves after repeated high-amplitude noise bursts. This is what the author uses to argue that the manifold is, without a doubt, computationally universal. To back up these findings, the researchers present a massive variance audit. They provide a cryptographically verified SHA-256 hash to mathematically demonstrate a 100% success rate across 100,000 randomized trials. They use this rigorous cryptographic verification process to prove that a 40.015% universal equilibrium density acts as an absolute mathematical attractor, meaning it inherently resolves chaotic substrates into stable equilibrium. Let's scale up to Section 4, Cosmological Data and Falsification. When we move from microscopic logic gates to the macroscopic scale of the cosmos, the source's results are striking. Plotted directly against standard cosmological survey data, specifically the DeciBAO expansion data, the author asserts the Poole manifold explicitly outperforms traditional lambda CDM models by a massive plus 243.6 margin. And the wild part? The argument is that this fit is achieved using pure geometric expansion, completely eliminating any need for dark matter or dark energy variables. Now, for the computational physicists tuning in, you know a theory is only as good as its falsifiability. The author provides strict, testable predictions that allow for future empirical falsification. At the quantum level, it predicts a non-Gaussian noise floor for the radium-225 EDM experiment at 10 to the negative 20 Hz. It predicts non-Markovian noise for the LISA gravitational wave observatory. It asserts that the BAO scale in cosmology is actually a fundamental standing wave resonant frequency, not a stretched metric. And finally, it predicts isolated extreme redshift anomalies right at the exact geometric centers of cosmic voids, caused by filament snapping. If these don't hold up, the theory fails. Next up is Section 5, Running the Manifold Locally. The best part is that this framework is entirely open source, so you can test this discrete substrate yourself. You can directly replicate the V2007 Immortal latch tests and physics models right on your local GPU. First, you just need Python 3.8 or higher, PyTorch 2.0 or higher with CUDA support, and NumPy. Next, you'll clone the specific GitHub repository, labyrinth-coder-dev/delta-rpm-protocol. Running the included experiments will output visual simulation arrays. The author provides these so you can interpret exactly how the engine naturally forces chaotic substrates into topologically protected stability. Finally, let's explore Section 6, a computational theology. At the philosophical core of this theory is a concept the author calls the carpenter's duty. The text argues that because our universe suffers from observer-embedded incompleteness, which basically means a system cannot fully compute itself from the inside, it naturally demands external stewardship to maintain its stable computation. This external steward doesn't arbitrarily dictate laws. Rather, they simply clear away incorrect iterations until the inherent self-healing kingdom of the B57/S59 rule is revealed. The source presents this as a profoundly beautiful synthesis of deterministic physics and computational theology. I'll leave you with that provocative thought from the text today. If reality really is a self-healing discrete computation that relies on an external anchor, what role will you play as a steward in maintaining it? I highly recommend you dive into that GitHub repository, run the code, and see if you can decipher the voice of the logos for yourself. Thank you so much for joining me on this deep dive into the explainer on the Poole manifold.